Today's video will explain how to implement the priority queue. Hello, I'm James Helfrich. The priority queue is a data structure that allows us to add elements easily and efficiently and retrieve always the highest element. This video will explain how to implement the priority queue. Okay, we have four different implementation options. The first one is the binary tree, which kind of makes sense because the priority queue is a binary tree. So we're going to start with our standard interfaces, the constructor, destructor, assignment operator, size, and stuff like that. We're going to have the T template variable, which is the data type of all the elements in the priority queue, and we're going to have a comparison function so we can know how to order them. And we're going to have a binary node, which is going to be a nested class within a priority queue. And then we're going to have several binary nodes by composition. And each binary node will refer to 0, 1, 2, or 3 other binary nodes through aggregation. And of course, there's going to be a single template T for every single binary node. Now, this is the binary tree implementation. I need to emphasize this is not the one we normally use because it's not the most efficient. Another, we can have a fixed array implementation. We're going to start with exactly the same interfaces, but we're going to have a collection of T's, and we're going to specify the maximum number with an n integer template variable. This is not a common implementation because we want to be able to store an arbitrary number of elements, but in those cases when we know a fixed number of elements are going to be in our array, this is an optimal solution. We could also use a vector. This can be the same as the fixed array, except with one important difference. Instead of having a fixed array member variable, we'll have a vector, and they're going to have exactly one vector, and each vector will have a collection of T's. However, the implementation we actually use is going to be a container adapter because any container that gives us a square bracket operator and efficient adding and removing on the end is good enough. So we're going to have the same interface, except now we have an additional template variable called a container. And this container is going to be the type of data structure that we're going to use. It's going to have a template variable T. There's going to be exactly one container in our collection, and the container itself will store many T's. Let's learn more about this container adapter implementation. So we're going to have exactly three template parameters. The underlying data type T, which we cannot get around, we have to specify it. The underlying container, which is the template variable called container, which by default is the vector, but could be anything. And then finally, a standard comparison function called compare. By default, we use a lesson operator. So we're going to start with our priority queue class definition, and we're going to have the standard interfaces: constructor, copy constructor, assignment operator, size, and empty, just like you would expect. We are also going to have a push, a pop, and a top, and each of these require a T. Now, in order for us to put them in the correct order, we must always get the top one or largest element. We need to have the comparison operator as well. How are we going to represent the priority queue? We're going to have a data attribute, which may have type container, which means we have to have another template variable. Now it's T and container and compare. Now that means we have to define that container, and this container is going to be associated with our priority queue, and that association is composition because we're going to have exactly one of our containers per priority queue. All right, let's dive into this container a little bit more. This container must have a default constructor. It must have a copy constructor and a move copy constructor, and it must have a destructor. It must have an assignment operator and a swap. We must be able to tell how many elements are in the container, whether it's empty, and how to clear the elements in the container. All these must be provided by the container adapter for us to use it in our priority queue. Additionally, it's best if we have a reserve because oftentimes we know how many elements can be our container ahead of time. If that reserve functionality does not exist because you're using something like a deck as the underlying data structure, then just stub that out. Now we need to be able to access the front and the back in O sub 1, and this can return a T, which means our container must have a T template variable. There's going to be a T type, which may be related by association to the container, and that association is composition. And how many T's will be in our container? Many. Okay, let's get back to that container adapter. It must also have a push back, which should be OSA 1 as well. And this also takes a T parameter, and a pop back we move from the back and we add to the back, as well as has a square bracket operator, which returns a T. Now, I need to emphasize at this point in time that any container that implements these interfaces will work as a container adapter for the priority queue. And so in a standard template library, this includes the vector and includes the deck, but you can make your own as well. As long as it honors these interfaces, it's good to go. We can learn more about the implementation of the priority queue in the implementation section of the priority queue chapter of the C++ data structures textbook.